Since colonization began in Canada, we've continually reshaped our landscapes. Forests were cleared for agriculture, homes were built, and networks of roads and infrastructure expanded. These changes have allowed communities to grow, but they've also altered natural systems, often with unintended consequences. Urban watersheds and the streams they support have been fundamentally changed. So how do we define a healthy watershed? It's not simply how green it appears or how many species it contains. Those are indicators, but they don't tell us how the system actually functions. A healthy watershed is one that performs like a natural system, where water, soils, vegetation, and streams all work together. If pre-development watersheds could support fish, then urban watersheds should be able to as well, if they function the same way. A watershed includes all the land that drains to a common outlet, such as a creek, river, lake, or ocean. Every surface, whether it's a roof, road, lawn, or forest, affects how much water flows into the river, how quickly it moves, and how clean it is. Watersheds function as integrated systems. What happens upstream directly affects what happens downstream. In coal mines, canaries were used as early warning systems. If the canary survived, the air was safe. In our watersheds, coho salmon serve a similar role. When salmon populations are healthy, it signals that the watershed is functioning well. And a healthy watershed supports not only aquatic life, but also healthy communities. This video series explores that shift, looking at how watersheds function, how urbanization has altered them, and how we can plan and design differently for healthy watersheds and streams. This video sets the context, how we got where we are today. Across Canada, many urban streams no longer support healthy aquatic life. Habitat has been degraded, water quality has declined, and in many cases, streams have been buried or replaced with pipes. Efforts often focus on adding habitat, such as spawning gravel, logs, and other habitat features, but these alone are not enough. The real issue is not habitat, it's water and water quality. In urban watersheds, the delivery system is too fast, we have polluted runoff, and we're too disconnected from natural systems. We rely too much on a pipe drainage system. This urban stream no longer supports fish. Much of it flows underground in storm drains. That section of stream was delated over 20 years ago, but fish have yet to return. The question is why? To answer that, we need to look at beyond the stream itself and understand how the surrounding landscape has changed. This photo is from a similar watershed shown in the late 1800s. Originally forested with wetlands and meadows, it was gradually cleared for agriculture and settlement. Early development introduced roads, drainage ditches, and small-scale land modifications. Over time, development intensified. More homes, more roads, and more infrastructure were added to the landscape. By the 1970s, the watershed had changed significantly. Roads were paved, and stormwater systems were installed to move water quickly away from developed areas. Water was no longer absorbed into the land, it was collected and conveyed directly to streams. Today, urban development continues to expand. More roofs and pavement generate more runoff. Two key changes drive this transformation: land cover and drainage systems. Land cover refers to what physically covers the ground. Historically, watersheds were dominated by forests and permeable soils. Today, many urban watersheds are dominated by impervious surfaces, roads, roofs, and hardscape. As impervious area increases, so does surface runoff. To manage this, we build highly efficient, engineered stormwater systems designed to move water away as quickly as possible. At the same time, channel density has increased. This includes streams, pipes, and drainage networks. In many watersheds, channel density is more than 15 times higher than it was historically. Together, these changes have transformed watershed behavior. Less water is absorbed into the ground and more is rapidly conveyed to streams. This results in higher runoff volumes, faster flows, and more frequent peak discharges. Streams become unstable, water quality declines, and aquatic life is lost. As designers, planners, and engineers, we shape these systems. The choices we make about land cover, drainage, and infrastructure directly influence watershed health. Before we design solutions, we need to understand how natural systems function. In the next video, we will look at how a forested watershed works and why it supports healthy streams.